Hi students, in this session we are going to discuss about Z transfer function. So in Laplace transforms modules also we discussed about transfer function. Here we are considering the transfer function in case of Z transform, that is here we are dealing with discrete time signals. So consider a linear time invariant system. So this transfer functions are all dealing with LTI systems. Okay, so LTI system, and this is a time invariant system, linear time invariant system with a discrete time. Okay, so ഒരു ഡിഫറൻസ് ഇക്വേഷന്റെ ടേംസിലാണ് നമ്മൾ ഇവിടുത്തെ ഇക്വേഷൻസ് എല്ലാം കൺസിഡർ ചെയ്യുന്നത്. വേറസ് ഇൻ ലാപ്ലാസ് ട്രാൻസ്ഫോം വി ആർ കൺസിഡറിങ് ഡിഫറൻഷ്യൽ ഇക്വേഷൻ. So this is the standard form of a difference equation, that is a raised to n a0 into y of n plus a1 y of n minus 1 plus a2 y of n minus 2 plus etc. equal to b0 into x of n plus b1 x of n minus 1 plus b2 x of n minus 2, like that. Now we are taking the Z transform on both sides of the equation 1 and we are applying zero initial conditions. Okay, so what is the Z transform of y of n? It is y of z. Y of n minus 1 is z raised to minus 1 into y of 0. Like that, x of n will become x of z and x of n minus 1 will become z raised to minus 1 into x of z. Okay, so we are taking the common terms outside. So in the left side, y of z is common. We are taking that outside. Y of z become y of z into a0 plus a1 z raised to minus 1 will be equivalent to x of z into b0 plus b1 z raised to minus 1. And we are rearranging that y of z by x of z. Our transfer function is of the form output divided by input. So we are considering the output of the LTI system as y and the input of the LTI system as x. So it will become y of z by x of z will be equivalent to b0 plus b1 z raised to minus 1 divided by a0 plus a1 z raised to minus 1. This 10 can be etc. We can put etc. here. Okay. So here we are applying Z transform. We are applying time shifting property of Z transform here for finding Z transform from the equation considering zero initial conditions. Okay, so we know that y of z by x of z is h of z. So h of z is known as the Z transfer function or system function, and y of z is the Z transform of the output sequence y of n, and x of z is the Z transform of the input sequence x of n. So therefore the system function can be defined as the ratio of Z transform of output to the Z transform of input, assuming zero and initial conditions. Okay, so if the input x of n is an impulse sequence, so impulse sequence means x of n is equal to delta of n. So we know that Z transform of delta of n is 1. So the transfer function is h of z will become y of z by 1. So that is h of z is equal to y of z. That is, which means that y of z is the Z transform of output. Here the output is impulse response, the output response of input. Therefore, when impulse response of the system is given in question, then the Z transfer function can be obtained by the taking Z transform of the impulse response. That is, Z of h of n is equal to h of z. Okay, so here we are having one question. So find the system function, that is transfer function, and plot the pole zero pattern for the following system. Okay, so they are giving one difference equation, that is y of n minus 2 y of n minus 1 plus 3 y of n minus 2 is equal to x of n plus x of n minus 1. So we know that system function, that is transfer function, is Z transform of output divided by Z transform of input, that is y of z by x of z. Now we are taking the Z transform of the both sides of the difference equation. We will get y of z minus 2z raised to minus 1 y of z plus 3z raised to minus 2 y of z is equal to x of z plus z raised to minus 1 x of z, and we are taking the term y of z, and in the left side outside, and in the right we are taking x of z. Then we on rearranging we will get y of z by x of z as 1 plus z raised to minus 1 divided by 1 minus 2 z raised to minus 1 plus 3z raised to minus 2. Okay, so next step is we need to find the poles and zeros, so we need to plot that. Okay, so first we are converting the negative terms in the h of z into positive terms, okay, by multiplying by z square. So it will become h of z is equal to z square plus z divided by z square minus 2z plus 3. Okay, so we are factorizing these two polynomials. We will get like this. Then from this equation, we can find the poles and zeros. The zeros are at z is equal to 0 and z is equal to minus 1. And the poles are at z is equal to 1 plus root 2j, comma, comma 1 minus root 2. Sorry, not j, it is I. So whatever it is, imaginary term. Then we are marking that poles and zeros in the real and imaginary axis of z. So we know that z is equal to r e raised to j omega. So it contains both real as well as imaginary part. So we are marking the poles and zeros, and we are considering this is z plane. So we are considering it as a circle. So we will get the figure as like this. Okay. So another question is y of n plus 6 y of n minus 1 plus 12 y of n minus 2 is equal to x of n minus 1 plus 2 x of n minus 2. So next step is we are taking is a transform on both sides, then rearranging it in the form of y of z by x of z, then factorizing that, then we are marking poles and zeros. Okay, so this is how we are considering the z transfer function.